In our last exercise working on sea ice, we focused mostly on sea ice climatology, or what sea ice was on average, both in the Arctic and the Antarctic. Now what we're going to do is work on the actual sea ice records. And what we're going to look at is now records. We're going to take a look at a time series of sea ice over the last 30 years or so. Again, we're going to be using the National Snow and Ice Data Center. So again, that is hashtag, I put this hashtag in here just as a note, pnsidc.org. And this is what the site looks like. We're going to be working with sea ice again. And we're going to be using the same product that we used last time, Sea Ice Index. And again, there's an overview of this data. Last time, again, we looked at the climatology on average, but now we're going to be looking at it from 1978 to present, and it's updated daily. And so we're going to see all those seasonal cycles every year and see if there are any trends in these data. And so to go ahead and download these data, again, we're going to be using FTP. And it says here that most new versions of web browsers block FTP addresses. And so they recommend using an FTP client. What we're going to do, since we're just going to be using it briefly, is we're going to go to this website here with Chrome flags, and I'll put that in here just as an example. And let's go back over to the site here. And if you put in FTP, you can see that we can enable support for FTP URLs. So we can just come in here and hit enabled. And if we relaunch our browser, it'll come up as it being enabled. And of course, when you're done with this exercise, you can just switch this back to default or disabled, either one of those things. Okay, so let's now go back to version 3, hit go to FTP, and it will bring up a directory listing. So let's start with the north first. We can go ahead and click on north, and we're going to look at our daily data. And let's go to data again. And last time we used climatology. Now we're actually going to be using the North Sea Ice Extent Daily version 3.0, right? So let's go ahead and we can click on this, and it'll probably download it as a CSV file or comma separated value. You can open it if you like. Here it is. And here's what you're going to see. You're going to see the year, the month, the day, the sea ice extent in millions of square miles, and the source data. So where this data actually came from. And we're going to be reading these. You can see there's hundreds and thousands of lines here. But this is just to give you a look at the data. So again, we're going to probably skip a line here and read this header in, and then we're going to keep going. So similar to last time, what I'm going to do is just right click on this guy. Let's copy the link address and put it here. So this is the actual address of where this file lives on the internet, and we are going to read in Arctic Sea Ice Index record. So these are daily values from 1978 to the present. Okay, let's go ahead and make an object here. We'll just call it arc, and we're going to use read.csv, that function again, just like last time. Our file is going to equal this thing. I'm going to read this, put that in there, and then there's a couple things that we need to do with this. Let's go ahead and let's say that there is a header equals true, and let's skip equals 1. So let's see if this works here. Go ahead and run this. Okay, so here's Arctic. We can go ahead and click on this. Again, here's years, month, days, millions of square miles. So here's 1978. Here's the month, here's the day. and we have all this data. That's exactly what we saw when we opened the CSV file over there. Okay, so now we have this data set, and we're really just going to be, in fact, if we take a look at it again, we're really just going to be looking at the first four. So we need our timestamp, which comes to us in actually 3 different columns. This is October 26, 1978, and also our value, which is in units of millions of square miles. So what we're going to do here is we're just going to overwrite arc, and we'll just say that arc, it's really just arc all columns, all rows, but columns 1 through 4. And so when we do that, you'll see that this now goes down to 4 variables, and if we take a look at it again, we'll just see that we have those 4. Okay, so that's our data frame for our Arctic. So here's one of the tougher things about dealing with time, is that we need to make a time variable out of the first 3 columns, right? So if we're going to make a time series, presumably we're going to have some kind of time on the x-axis, and on the y-axis we'll have our square kilometers. So somehow we have to combine these 3 columns into a timestamp. And so the way that R does this, let's just say this, let's combine first 3 columns into a proper timestamp, right? So we'd like to have one timestamp to plot here. And so the way that we're going to do this is we're going to create a object called arc_time, and we are going to use the paste function. We're just going to paste arc column 1, arc column 2, arc column 3 together, and our separator, when we paste them together, is going to be a dash, just like that. So let's go ahead and run this. So what is this going to do? Like before we run it, it's going to paste this guy with this guy with this guy and put a dash in between them. So that's what this notation means. Okay, so now we have arc time. Large character, it's big character. So let's take a look at it. Oh, we can't click on it. Let's maybe just do this. Let's just do the head of arc time. And there it is. There's 1978, 1026, 1978, 1028, and so on and so forth, right? So this is data that's coming to us mostly daily, although these look like maybe every other day. I think eventually it turns into daily data. But this is still not a proper time that's recognized by R. And so we're going to use a special function called strp time. Okay, what is strp time? Okay, so this is a really powerful function. Strip time, it asks, here it is here, it asks for an object to be converted into a POSIX LT, which is basically a time. Now, one thing that's a little bit weird about computers, well, not weird, it's actually weird about human beings, is that we keep time in all different kinds of ways. We do days, we do hours, we do minutes, we do seconds, we do AM, PM, months, day of the week, quarters. We have leap years in there, and we have to figure out how to translate all that stuff into a time format that R actually understands. And so what we are going to do is we're going to tell strip time that we want to convert arc time, this thing right here that we just made, into something, and we just have to tell it what the format is. The format of this timestamp is what? Well, the first thing that comes is a year. And so to tell strip time that that is what it is, we put it in quotes, and then we use a %, capital Y, to denote year. And in fact, if you come down through and read this entire thing, these little % and A's, they mean different things to strip time. So let's just come down here to capital Y. You'll see here, capital Y is year with century. So that's what we have here. We have a year with a century. So that we're telling that strip time, that the first thing that we pasted together in here, this unit here, is year with century. Then we're going to have a dash. Then we're going to have a dollar or a percent sign again, and we have month. So if we scroll up here and we see M, this is months as a decimal number. That's lowercase m. So we're going to go ahead and put M there, because that's what we have, lowercase m. And then we have day. So maybe let's scroll up here and see if we can find something for day. Here's day of the month as a decimal number. So we're going to do $D. And so when we do that, we tell R what sort of format our data is in, and then we need to give it a time zone. Now, time zone, in this case, is going to be GMT, Greenwich Mean Time. So that is sort of a universal timestamp for the Earth. It's often used in scientific data. So let's go ahead and run this. And so now if we take a look at this, head, arc, time, you'll see that it looks almost the same, except you see this GMT timestamp, and this is now a proper timestamp that R can understand. And so now we have a time, and so this is our time. This will probably be our X variable, and then our Y variable is going to be our millions of square kilometers here over in this object called arc. So we have two different columns, or two different objects there that we'll be working with. Okay, just to make things a little easier, let's go ahead and make arc, let's call it sea ice extent is just equal to arc column 4, right? So that is going to be, we're just going to be taking this guy right here, that's the 4th column, and we're denoting that by running this piece of code right here that we just have these values here. And so luckily, look, we've got arc time with 14,281. We have arc sea ice extent now with 14,281, and we should be able to plot those together. Let's now read in our Antarctic data. So maybe just put a note up here. Let's go ahead and instead of this, I'll just copy this, and I'll just change the notation to reading in Antarctic. And how do we find Antarctic data? Well, let's, we can, in fact, it's probably really close to this, but we can go back to our FTP site. Here, go back to the parent directory, back to the parent directory, back to the parent directory. Okay, now we click on South, Daily, Data, and now we're looking at the daily sea ice extent here. So let's go ahead and copy this link address. All right, so this is what we're going to use in here. So, in fact, I'll just put it as a little holder for us here. Now we're going to use ant. This is our Antarctic. We're going to use read.csv again. We're going to put this in quotes, which is what we just put right there. That's our file. And it has a header. And we're going to skip equals 1. So now we're reading in our Antarctic data. Run. Okay, here it comes, right? So here is Arctic, here's our Antarctic, right? So let's go ahead and take a look at the Antarctic. It's really similar to what we saw before, right? So here's our year, day, year, month, day, millions of square kilometers, and then here's our source. And so we're going to do something really similar to what we did before. And one nice thing here is that we can just copy this data, and instead of arc, we're just going to put ANT, because we want to do the same operation that we did to the Arctic. We'll go ahead and run that, and you can see over here now it's just 4 variables. What do we also have to do? Well, we have to make a timestamp. So let's come back over here. Instead of writing it all out again, we can copy this. We can use this as a template and just say this is going to be our Antarctic time. We want to paste ANT, so that's the first 3 columns of ANT, and we want our Antarctic time. ANT has the same format, and then we'll do ANT here and ANT here, right? So if we take a look at our ANT again, here it is. Here's our first 3, We're going to paste those together in a date. And so we can go ahead and run these two. Good, and just confirm here that our Antarctic time is a proper time. Yes, it is. And our Antarctic sea ice is going to be our fourth column. Okay, so now, just by copy and pasting and modifying the code a little bit, we've made quite some progress. Okay, so let's go ahead and plot our Antarctic sea ice extent. So let's go ahead and do that. Let's plot. Maybe I'll add a little note here first. On the same graph. Okay, we're going to put these on the same graph. All right, so let's go ahead and do this. Let's start with plot. Let's start by plotting Antarctic data. ANT_time, Antarctic, SIE. So we're just going to start real simple. Let's plot the Antarctic data and go ahead and run. Okay, there's our Antarctic time. You can see that's being interpreted as years, as it should be. And here's our Antarctic sea ice. There it is. Okay, this isn't the prettiest plot around, so we're going to change a few things up. Let's go ahead and make the type equals a line. Make that a little easier to read, maybe. There it is. There's our Antarctic sea ice. So you can see all the different seasons. Looks pretty stable overall, maybe. Maybe it's dipping down. Looks like there was maybe a new low here. Let's see if we can add something else to this. Let's increase the line weight. If we increase the line weight to 2, it's a little easier to see. That looks a little nicer. And what else are we going to do? Let's add an X label. Is just going to be date. There we go. You can see that date's down here. That shows up. Let's see, what else can we do with this thing? Let's go ahead and put in a Y label. And our Y label is going to be millions of kilometers square. Okay. And maybe a main plot here. This is what? Oh, maybe let's just leave that for now. Millions of square kilometer. Well, maybe we add sea ice and then put this in parentheses. That'll work. Okay. Millions, so this is area of sea ice, millions of square kilometers. Okay, so far so good. Now, let's just for fun, let's do the same thing now with the Antarctic. I'm sorry, the Arctic. And we'll just change this. And let's just run this plot. And you can see that it's quite different. You can see that, you know, it looks like maybe there's a downward trend here on the sea ice, but we want to put these on the same plot. So I'm going to just, whoops. Yeah, we'll remove that plot. In fact, I'll hit this little sweeper, clear all the plots out. Let's start over with this one. Okay, and we want to add Antarctic to this. How should we do that? Let's go ahead and put I'm going to add a function called lines, and our lines is going to be our Arctic and our Arctic time and our Arctic sea ice. Line weight equals 2. In fact, we don't need this anymore. We can get rid of this. So this should put it on the same plot. It does, but now it looks really confusing, so we need to give it a different color here. Let's go up here and let's do color equal gray for the Antarctic. And we'll do color equals black for the Antarctic. I'm sorry, gray for the Antarctic, black for the Arctic. And you can see them a little bit better, right? So here's the Antarctic in the background with the gray. Here's the Arctic, and you can see already that even the range of values between the Arctic and Antarctic are quite different from each other. Okay, what else would be helpful on this plot? Maybe let's give this one a main. Daily sea ice from 1979 through 2022. Run that. Okay, so we have a little better description of what's happening here. Okay, let's give this thing a legend. So, let's do a legend. Where should we put this legend? Well, it doesn't look like that we have room down here to put a legend. So let's do this. Before we add a legend, I'm going to come up here to our plot command, and I'm going to add a ylim command. And so this is going to let us set our y limits over here. So it's concatenate. We got to put two numbers in here. We're going to use a ylim of 0 to 20. So if we do that, you can see that now we have a little more room down here. Added a 0. We'll add the lines on top. So it looks like we have a little room down here, a little white space down here that we'll be able to add a legend into. So let's do, just like before in our last video, let's put this at the bottom right. Our actual legend text is going to be, what? What are we going to do? Arctic and Antarctic. Oops, gotta make sure I have quotes there. Antarctic, okay. Okay, so if I run a legend here, okay, I have Arctic and Antarctic. It doesn't look wonderful yet, so let's keep working on it. Our line weight equals 2. Our colors of these lines for the Antarctic is black, right? Oops. And it's gray. Sorry, it's black for the Arctic, gray for the Antarctic. So if I just run the legend again, you'll see that it overplots on top of it, which isn't exactly what we want. Let's go ahead and make this thing, this box is sort of getting in the way of the data. So I'm going to do bty as box type, bty equals none. Let's see what happens there. Okay, Arctic is still sort of in the way there. So let's do horiz equals true. Okay, that's much nicer. All right, so here we have a really nice long record of, we're starting in 79 or 80, and we've got, what, 20 years here, 30 years here, almost 40 years, a little more than 40 years of sea ice data. That's really nice. You can see what the trends are. So we see really, really big seasonal signals here. And that's what we saw with the climatology, right? So things really change in the summer there versus the winter. But then in the background, you can maybe detect here that there's kind of an overall trend for the Arctic and the Antarctic. And so one way to deal with that, to not always have to look at all these squiggles, is to decide that maybe we should just be plotting 1 month a year, right? So instead of plotting all the days, let's just plot 1 month a year, the same month every year, and look to see if we can actually detect a trend. So that's what we're going to do next. So we're going to go ahead and we're going to read in extent for March and September. So March is probably when sea ice is going to be at its sort of lowest value in the Antarctic, probably highest in the Arctic, and just the opposite here in September. So we have to go find this data. So where do we find this data? So let's go over to our FTP site again. Here we are. Let's go to our parent directory. First, let's go to the Arctic. So let's go back over here to north, and to monthly data. And so here's north. Here are the months. So this is January, February, March, April, May, June, July, and so on, all the way down to December. So if I want to take a look at March in the north, I can click on this. Let's take a look at this real quick. What does this look like? Looks like we have year, month, data type, region, extent, and area. So from what? This is from 1979 all the way to 2022. So pretty cool. All right, so let's go ahead and read that in. Arc March equals read.csv. We need now that FTP site, so we need the actual site again. Let's read in March. So let's copy the link address, and we'll put that right in here. Again, that's our file name. That's our file. Header equals true. So let's go ahead and read this in. Run. So here's now Arctic March. Let's take a look at that. So here's year, month, data type, region, extent, and area. Okay. And then let's now also read in September. Arc September. Again, if we take a look at this thing, we can probably guess what this file path is actually going to be. We have this FTP, we're going to this computer, and it's probably going to be north, 09 extent. So let's see if we're correct. So let's go over here. There it is, 9 extent. Let's copy the link address and read.csv. Boom, there it is. Header equals true. So that's our Arctic September. Let's run that. Okay, looks like we got that. Arctic September, there it is, 1979, month 9, all the way through. And we have extent and area. Good. Let's go ahead and read in our Antarctic version of this. So we can copy both of these. In fact, I'll copy this entire thing. Let's read in the Antarctic. Sea ice extent in March and September. So this is going to be our Antarctic. This is going to be our Antarctic September. Okay, can we guess what this is going to be? This is probably going to be not north, but south. And our data is not going to be from the North March, but it's going to be from southern. So let's just confirm that real quick with our FTP site. If they have it organized the way we think they have it organized, let's go to the parent directory. Up over here, monthly, whoops, gotta go parent directory, we're still in north. Let's go to south. Let's go to monthly, and let's go to data. And so here you can see what the, index south monthly data, that's over here. So here it is, south monthly data, south 03. That's what we want for our sea ice extent. There it is. South 03 extent version 3. And then we'll do the same thing for September. Okay, so all we got to do here is change this to south and this to S. And we should be able to read these two things in. Boom. Okay, there they are. So here's our Antarctic March data, our Antarctic September data. Okay, that's pretty good. All right, let's go ahead and plot these up. So let's plot Arc March 1. What is Arc March 1? Arctic March 1, that's our year. And again, this is our, we don't need to paste things in here together. Since we just have 1 month per year, we're just going to put the year down. and then we're going to plot the extent, the fifth column. Arc March 1 and arc Mar 5. So let's run that and see what that looks like. That looks definitely like a downward trend here. Let's go ahead and add some things to it. Let's do type equals O, overplot equals 2, our Y label. Let's do our X lab first, actually. X lab is going to be our year, and our Y lab is going to be our Arctic sea ice extent, and this is going to be in, we'll just do this notation, 10 to the 6th, so that's 1,000,000 kilometers squared. Let's go ahead and run that. Yeah, okay, so you can see that at least in March, we've dropped quite a bit in Arctic sea ice. So that's pretty interesting. And we can compare that, say, to September if we want. So, what should we do there? Let's take a look at, well, maybe we'll just add this. March Arctic sea ice extent. There, that's a little better. Okay, let's make another one now for September. So what's nice is we can just edit these, and we should be able to pop out. I'll just put Sep. I plot pretty quickly. September also looks like it's going down. That's pretty cool. All right. Maybe we want to put these on the same graph. Let's do that. So we can start with this one. Plot. And then we're going to add points. Basically this command here. And this is no longer just March, since we're going to have March and September. We just see one line. Well, why is that? Well, probably because September is much lower than this, so we need to adjust our Y lab. Let's adjust this too. Okay. Y lab equals, Y lim. Zero to 20. So let's go ahead and put that on here, Arctic March. Okay, now we're putting it 0 to 20. That's the same data, but it's now squished down. All we did was adjust the y-axis here, but we should be able to now put our September data on it. And they both sort of have a downward trend. Okay, so that's Arctic sea ice extent. Let's put a legend on this thing. X equals, oops. Bottom left. I'll put the legend down here. So our first line is going to be March. Our second line is going to be September. And we need to make these different point characters because they look exactly the same. Maybe we should change colors for them, possibly. Let's do different point characters this time. So for this one, this first one, we'll do a PCH equals 1, point character 1, and for this one we'll do PCH equals 20. So that's a solid dot. So let's go ahead and run that. There we go. So now you can tell them apart. And our point character in our legend now is going to be 1 and 20. So if we actually run this, you'll see March and September. There you go. Those are two different ones. So again, let's go ahead and do bty equals n to remove the box, and horiz equals true. Okay, so there's March, there's September for the Arctic. Now, what's nice is that we can basically steal or copy all of this and make an Antarctic plot. All of this stuff. So let's go ahead. In fact, you know what? Let's not just do that. We'll even copy these guys up here. So let's just plot just the Arctic, just the Antarctic, March, just by changing this. And now this is March, Antarctic sea ice extent. So what does that look like? Okay, March is maybe getting more variable with time. Maybe down, maybe not. Hard to tell. And now let's take a look at September. Again, we can just change our object names here. We don't have to retype everything every time. Let's take a look at September. Oh, okay, so yes, high, low. Hard to tell exactly. Maybe it's flat, maybe going down, although it's spiked way up here. Maybe not further down. And then let's take this combined plot here, and let's make this Antarctic, ANT, ANT. This is now Antarctic sea ice extent, ANT. What's great with this is that once you have your code, once you write it once, you can always modify it. And is there anything else that we want to do here? I think we can run this whole thing. There it is. So there's March, there's September. So maybe we can compare those two now. Again, right? So we've taken all that seasonality out of it. Okay, so you've computed those. You can take a look at other months if you want. You can easily go back into this file server and pick whatever month you want and use the same code. You just have to modify it a little bit to plot your different months. And as always, you're going to want to save your code here. So we'll do a file, save as, go ahead and give it a name, stick it somewhere that's important to you. You know, maybe I want to put this in my, you know, if I've got a certain folder for this class, I might call it Sea Ice Records, Sea Ice Records. So now I have that here, and if you want to export any of these plots, right, so you can loop through all these plots. If you want to take a look at any of them, or you can clear them out and, you know, recreate whatever plot you want. So you can just run that, and you should be able to export this, copy it to a clipboard, and then copy it to your file. Now, if you really get, you know, messed up, you can always come in here and clean everything. Let's clear everything out, clear all the plots, yes. Then if I try to run this little bit of code down here, it's going to give me errors because it doesn't know what anything is. You have to go from the very top again. Go ahead and copy everything, and it should reproduce all of your plot. And that's the nice thing about this code. It's just like a recipe. You just hit run, and it will do everything for you. See? And you got all your plots back. Okay, thank you.